entertained while you're learning a lot of things. So I am from the Philippines along with some of the members here. And again, I am Joshua Arvin, the Chief Technology Officer of Complete Business Online Insights and Jepto. So to start off with, I want to make sure that that we all understand where we're coming from, especially on the definitions. So later, I'll be sharing the definition of serverless as as my way to introduce things, and then I'll also share how we transform our tech stack from the previous tech stack into the new one. Basically, letting you know that it's not just a tech stack transformation. Basically, it's transforming the way companies work, the way our organization works. Second, I'll be talking about the serverless ecosystem, AWS Lambda, DynamoDB, AppSync, etc. Even code build, code pipeline, everything that's serverless. I'm going to discuss these things in detail to help us understand how things work with each other. And then next, I'm going to talk about the patterns and anti-patterns now that we're focusing more on the coding part. So sometimes we worry too much about the infrastructure, and given that we're focusing now on the serverless architecture, we're going to deal more with code. And then finally, as a member of the management team, this is one of the things I always have to worry about. So team structure and management, cost, and then finally, how to measure what we actually did. So context. So everybody has a plan until they get punched in the face. So the reason why I'm sharing that slide is a lot of us have our own ideas. A lot of us think about ways on how things could work. But the only way for us to know if things are working or not is, have we even tried this in production? Have we tried this in a staging environment? Have we simulated our ideas? Unless we do all of those things, we won't really know what really works and what doesn't. When you read the blog post, the problem there sometimes is you read all those ideas, and then when you try it, it doesn't work like that. Some things may not be as smooth as what you think they are. And I'm here to tell you that migrating everything to serverless is not an easy task. You have to plan at the beginning. You have to make sure that everything is in place, and you have to make sure that you have to have every detail planned out. Otherwise, you may end up refactoring some parts of your code because you were not aware that such problems exist. So let's start with who I am. So this is just a 30-second description. So I am the Chief Technology Officer of 3 Australian-owned companies. And I'm also one of the AWS User Group Philippines core leaders. In the past, I am the Director for Software Development and Engineering in 3 startups, and so on. So I am almost fully certified except for Cloud Practitioner. So I find it a personal challenge to take on all of these certifications. But in the beginning, I wasn't really a fan of certifications until I realized that actually getting this would help you prepare for work. Sometimes people end up trying to learn all of these things at work, then when they encounter problems, that's when they start to learn it. My way of working is by researching it, trying it out, making sure that I'm ready before using it at work. Because your company is paying you for the work that you do for them. And I have updated this slide because I recently got the machine learning specialty exam done. So there were no references online, and got to use my previous experience and did a bit of research, a bit of investment on learning and trying things out, because in my current company, we're using machine learning in one of our products. So I'm not going to talk about that because this topic is about serverless, but I'm letting you know that being prepared will help you with a lot of things. So let's begin our little activity. So everybody, please stand up and we'll have a quick activity. So you won't be standing up for more than 3 minutes because I only have 20 to 30 minutes to do my talk. So everybody stand up. I have some props. Right, so we have a simple game. So whoever has this bottle or jug, when I say stop, has to go up here in front and be part of the force volunteers. So the goal here is to tell a number, and then when you give it to another person, you have to sit down, and that person adds 1 to the number. Okay? So what's your name, sir?
Right.
So how many letters in your name?
5.
5. Alright. So that's 1. And then 2. And then 3. Then you can sit down. 3 and then 4. And then 5. And then 6. So 1 to 5 sit down, because if Clyde has 5 letters in it, so 1 plus 5 is 6. So number 6 go up here. Congratulations on being a force volunteer. Alright, so okay, let's give him a big round of applause. Alright, force volunteer. So what's your name, sir? Raja? Alright. So number 7. 9. And then, who do you want to give it to? 10. Alright, so sit down, and then number 10, come up here. Congratulations on being a force volunteer. Okay. Okay, so what's your name? How many letters? 5. So you're number 10. 10 plus 5 is 15. Alright, so you're part of the force volunteers. So 11, 12, 13, 14, and then 15. Alright, so welcome, number 15. So come up here in the stage. Thank you. So what's your name? 7. So your current number? 15. Plus 7. 22, right? Alright. So 16, 17, 18, 19, 20, 21, 22. Alright, number 22, come up here in the stage. Alright, thank you very much. So don't worry, you won't be here for more than 5 minutes because the talk is short. 5 minutes. So, sir, what's your name? Alright. So, before we start, so arm sideboard raise. Right arm sideboard raise, so you can pull it. So let's give them a big round of applause for volunteering. Alright. So this will be a quick serverless activity. The reason why we have to show it here is it allows us to visualize things better. Being able to count from 1 to X and being able to pass through each one of you, I wanted to demonstrate an example of you guys being the Lambda functions. You have the input, let's say 2, and then there's the stateless function which adds 1, and then it increments it and then passes it on to the next function. And then that function has a purpose. So as humans, we have purpose, and it gives us the capability to divide things better. So what will be the force volunteers be doing? So I'll put this back here. So let's divide this group into 3 parts. Alright, so these 2 people here, please be farther away from them. And then this person here. Yeah. And then, sir, what's your name, sir, again? Manoj. So, Sir Manoj. So, Sir Manoj will be the stateless function. And then, this will be your APIs. So, let's say, so can you give me one API from AWS that you usually use or you want to use in the future? So S3. Alright, so his example is DynamoDB. And then you're the stateless function, you're the Lambda function, and can you provide one more like API of AWS? Any SDK like S3 again? EC2. Alright. So we have EC2, we have the Lambda function, we have DynamoDB, and we have S3. So here, when you're using a Lambda function, the first thing you have to think about is, what is its purpose? Of course, later I have to tell you that Lambda functions and functions as a service does not necessarily mean serverless. Or the other way around. Basically, serverless doesn't necessarily mean function as a service. If you use S3 and with Angular code in it, it's technically serverless because you don't have to manage infrastructure with that. Okay? If you're using EC2 instances and you're maintaining the infrastructure underneath that service, it's not serverless. And so here, let's begin. So you have EC2, let's say events. So you trigger an event or something, and then you have properties. And then this Lambda function gets triggered by an API, for example. So when he goes to you, you have to say, like, emit event or something. So,
Emit event.
he told us emit event. So you're going to say processing. Right? So here are our prompts. So here's your input. So this is, I'm not sure what this is. It's a bottle. Yeah, so I think it's a bottle. Yeah. So you give this person and have the Lambda function process it as the input. So let's say this is the event data. Alright. So now that he's processing, so say again, processing. And then during that Lambda function, he is supposed to customize whatever he wants to do, which is part of the business logic. And then the data gets stored in S3 and DynamoDB. So when you receive it, just tell him, I receive it and I store it in the database or store. Alright. So
Processing. Stored in the database.
So now, you have something like this which allows you to separate state and stateless. Okay? Stateful and stateless. So now, let's say that a lot of things are happening behind the scenes. So now, I'm going to recruit you and make you a second Lambda function. So you're no longer S3, right? Or DynamoDB. So you're no longer DynamoDB, you're now another Lambda function. So these two people will be here and you will be running things concurrently. So the data source will say, pass it to the first Lambda function as an event, and then give it to S3. Alright, so let's say that a file has been generated in S3. And then, while that is happening in a different universe or something, you say, providing data again. And then the other Lambda function, he will receive it.
Processing.
And start in S3. Alright, so now there's a distribution of responsibilities between the source and the function processing it, and then finally the final output storage. So basically that's how, that's one of the advantages of serverless and basically microservices in general. And with serverless, you don't have to worry about the infrastructure underneath. You can technically do the same thing with EC2 instances running here, instead of Lambda functions, but with, let's say, Lambda functions and the serverless stuff in general, you just have to worry about the implementation side. So let's give them a big round of applause and thank you for volunteering. Right? We now go back to yours. Thank you. Thank you. Thank you, sir. All right. So going back to our original program. So we'll have 2 more activities later, so stay tuned. So serverless ecosystem, if all you have is a hammer, everything becomes a nail. So what do I mean by that? Remember the thing that you saw here? In AWS, you have a lot of services running. Each service has a purpose. So if you only know 2 services, let's say PostgreSQL, and there may be a better database to be used instead of that database for your use case, then better use that tool. If you have one tool that's only suited for a job, you can technically use it for other jobs, but it may not be optimal to use that for that purpose. So here, being able to know what AWS Lambda can integrate with will help you. So the reason why I used humans as examples to demonstrate communication is these distributed items need to communicate with each other, whether in the network, whether by an API call. But as you can see, they were able to communicate via the API. And the advantage of using serverless is instead of you trying to worry about the installation of something or doing something that does a custom thing, why don't you just focus on the business logic and it will work right away? So being able to use AWS Lambda as the glue to connect things together will help you a lot. So I'm not sure if the background is just missing, but in the background, it's supposed to show the different services that AWS Lambda can integrate with. But with serverless, let's say you have to work on continuous integration items, you can technically trigger code build and code pipeline APIs with Lambda function, which is what we do in our current company. It allowed us to just give the developers an instruction, do this, do that, given the documentation in AWS pretty much complete, or at least it allows you to get started right away. It allows you to use these services and automate things because that's one of the advantages of using the AWS SDKs and APIs. So now, let's talk about one of the more detailed things that you have to think about when you're using serverless technologies. The first thing I told you is that there are a lot of options right there, and when you're trying to architect things, you have to think about the different options. But that's the first part. The second part there is about thinking how you can maximize existing tools. So for those who have tried to use serverless applications in the past, who have tried building them, and when you're using Lambda functions, for example, sometimes you will find limitations, or sometimes you have too many Lambda functions that you have to centralize them and put it somewhere. So one thing that you can use in AWS Lambda is the AWS Lambda layer. In a previous joint meetup between the AWS user group and the R users group, we had a quick demonstration on how to run our scripts or our code inside a Lambda function. So if you're aware of what's supported in AWS Lambda, so before it was just Python, JavaScript, etc. And then the other languages followed. But here, given that there's support now for AWS Lambda layers, and you can technically create your own Lambda layer, it allows you to create your custom runtime. And here, you can see at the upper right side of the screen is that you can technically write your R code as if it was a Python function. So I checked resources online and modified it a bit so that it will look like how it behaves as if you were using Python. So if you have data scientists that just know R and have no idea how to use Python, for example, instead of you trying to force them to use a different language, you can do this technique and have them write it here. Alright, so last 5 minutes. So now I'm going to talk about the patterns and anti-patterns of using AWS Lambda and the serverless ecosystem. So give me 6 hours to chop down a tree. I will spend the first 4 sharpening the axe. No idea what's happening. Anyway, so what was the slide there again? Just remember. All right. Thank you. So I spent something 4 hours, chop the tree, use the axe. Oh, patterns and anti-patterns, all right. So let's say that you are building an application and you have your Lambda functions. What do you need to worry about when using Lambda? When you try to read documentation available, you'll always have to worry about what you read there. But when you're doing things in production, one thing you will always forget is if you run something and have different people try the same thing, they will come up with different results. The problem there is when you don't have standards in your company, or even if you have standards in your company and you have like 20 or 30 developers in the team, even make it smaller, like 5 or 10 people, the problem there is they will have their own conventions. Even if you use Lambda functions and each Lambda function has its own execution environment, the problem there is the Lambda function can be abused. And you may try to put everything there in your Lambda function. So what I can suggest here is to learn the design patterns and coding techniques when using Lambda. So the first one is, let's say, having a light validation layer on top of your function on the input side, just to know the structure of the data. And if the structure is wrong, then have an error. Then you can also have a light validation layer on the output, check its data structure, and then if it's okay, then have it pass through. So knowing the input, the output, and the purpose of the function will definitely speed up the knowledge sharing time between two developers, and it can check things during runtime. So some people will tell you, oh, let's use automated tests, let's use TDD, etc. Sometimes the investment is way too high, and the discipline part there cannot be really maintained. So that's one technique on how you do it. The second part is making your functions idempotent. So for those who heard the word idempotent the first time around, I'm going to have a quick demonstration. Alright, so you remember your numbers, right? So now we have a different game. So idempotence is one of the things you have to take note of, but here's the technique. So the goal here is for you to give this bottle to someone who has a different colored beanbag. And once the count reaches 8, then the number 8 goes here. So sir, give this one, so 1, to a different color. 2, different color. 3, and 4, 5, 6, 7. What's the lucky number 8? Oh, the one in the front. Oh, so number 8, please come up here. Congratulations on being selected. Alright, so can you give it to another person? So please stay up here in the front. So that's 1, 2, 3, 4. 4, 1, 2, 3, 4, 5, 6. Everybody's scared of the first. 7, I'm not sure what the count is, and then 8. Alright, number 8, come up here. So we'll have a 3-minute example of how idempotence work. So we just have 2 volunteers here, and we're going to use that as input. So what is your name, miss? Okay. And what's your name? So let's give them a big round of applause for volunteering. So So let's say this is their data. So let's say that there's a retry which happened during the execution. So sometimes people will just do try catch concepts and they will expect things to work right away. But when they are dealing with different things and things are not really connected in any way, except for the data and the events which are happening, let's say you hold this and you give it to her the first time around. So let's say that you want to have a transaction of adding 20 and 30. So you give it to her, then you say you receive it. Alright, so now, what happens if there's a retry? So your current value is, let's say, 50, and then suddenly the transaction happens again. So you give it. Alright, so 50 plus 20, it's supposed to be 70, right? So the trick here is to make sure that the function that's processing the data is sure that it has to come out as the correct number, even if it has been tried multiple times. It protects the integrity of the data. Okay, so that further assumptions in the future are much easier to make, especially if there are protection code like that. So that's idempotence. So let's give them again a big round of applause for volunteering. Alright, so we're almost done. Thank you. And that's one of the things you have to worry about when thinking about Lambda function. And then finally, for the feedback cycle, you have to worry about if developers can actually test their code and test their work in their local environment and staging environment. And then finally, for management considerations, you can't manage what you don't measure. So knowing the team structure at the beginning and knowing what serverless is trying to help you with is the ownership. So serverless, the way you divide things is with the microservices examples, where when you have a microservice A, B, and C, microservice A has a purpose. And if there's a bug with that purpose, you fix it there, and you don't want microservice B and C to even know that such things exist. At least there's separation of concerns. So before, when you have a monolithic architecture, you just have one big team and then you expect them to finish things in 6 months or something. But when you have that kind of separation of duties, it allows you to divide teams further, and they have ownership of something. It allows us to measure if people are actually doing and have output, and things are more predictable that way. It allows you to observe things much further, given that things are separate on a function level. And then finally, on the last slide, we have the non-functional requirements. Sometimes when you have to prove it to your owners or to your bosses, sometimes you will just read the blog post and tell them, this will work, this will make things more observable, things will be more scalable, but at what expense? Sometimes when choosing a different tech stack, you will definitely lose something in order to gain something. So you have to measure, and there's no single answer to all of that. So let's say scalability, manageability, even performance. Let's say that you divide the function into 4 different Lambda functions and have an API gateway to have some sort of layer and have them communicate. Maybe you will encounter some things in the NFR aspect that you may not be able to measure right away, especially if you're just trying to make things work. So basically that's NFRs, and that's critical if you're part of the management team or you're someone who's trying to introduce serverless technologies in your companies. And then finally, this slide is just here to tell you that everything's interrelated. You cannot just introduce serverless and expect nothing to be changing except the tech stack. The way people work, the way people check the output, the way people assess the quality of your projects, it's all interconnected. So that's it. That's the summary. I was able to tackle all parts and show you a quick demonstration. And thank you again, and hope you learned something from my talk.